Hello, this is the section 2.3 and 2.4 lesson. Now, the main topic of these two sections is comparing fractions. So we're going to start off with a reminder of a couple of definitions. The first definition is of a fraction. And so a fraction, of course, looks like this. It's a number over a number. The bottom number, called the denominator, is the number of pieces in the whole. So when we work with fractions, we always start off with a whole. We take that whole and divide it up into several pieces, and that number of pieces becomes the denominator. Now, the numerator, a, is the number of pieces that we have selected. So a fraction is all about taking a whole, breaking it up into several pieces, and then selecting several pieces. And we're going to use that idea a lot in this section. Second definition that we want to remind ourselves of is the meaning of multiplication. Multiplication deals with when we've got several groups. Each one of those groups contains a certain number of items, and we multiply those to get the total number of items. So we're going to use the meaning of multiplication in some of our ideas today. Now, section 2.3 deals technically with a subject called equivalent fractions. And equivalent is really just another name for equal. So the definition of equivalent fractions is that two fractions are equivalent if they represent the same quantity. Again, just another idea, just another word for meaning that the fractions are equal. So let's look at an example. Let's take the fraction 3/4. And right here we have a picture of that fraction 3/4. So we start off with a whole, this big long strip here. The denominator 4 means that we're going to divide that whole up into 4 pieces. So we have 1, 2, 3, 4 pieces there. And then the numerator 3 means that we are going to select 3 of those pieces. 1, 2, 3. So that picture there represents this fraction 3/4. Now here we have taken the numerator and the denominator times the number 5. And if we do that arithmetic, this would be 15 over 20. And so the fraction 15 over 20 equals the fraction 3/4, so those two fractions are equivalent. So now we all know that if we multiply the numerator and the denominator by the same quantity, we get an equivalent fraction. But now the next question is, why does that work? Well, let's use this simple example to try to illustrate why this works. So we're going to draw a picture here of this fraction 3 times 5 over 4 times 5. And so let's start off with the denominator. 4 times 5 means that we're going to take our whole, which is going to be this big long strip, and break it up into 4 groups of 5. So here you see 1, 2, 3, 4 groups. And then in each one of those groups we have 1, 2, 3, 4, 5 pieces. And so there we have divided our whole up into 4 groups of 5. Now the numerator, 3 times 5, means that we are going to select 3 groups of 5. So you see how we've selected 1, 2, 3 groups. Each one of those groups contains 5 pieces, 1, 2, 3, 4, 5. And so there we have selected 3 times 5 pieces. So now if we compare this picture here, which represents this fraction 3 times 5 over 4 times 5, we compare that fraction to, or that picture to this picture, which represents 3/4, we see that these shaded regions are the same. They represent the same quantity. And so our picture here illustrates that these two fractions really are equal. And you see how we've used the meaning of fractions. We've also used the meaning of multiplication to explain why these two fractions are equal. So let's kind of look at this from another perspective. Again, we're dealing with this same fraction 3/4 equals 3 times 5 over 4 times 5. And here's our picture that we just drew. From another perspective, we see that when we multiplied this numerator and this denominator by 5, what we really did was broke each one of those pieces up into smaller pieces. So we started off here with 4 pieces in our whole. When we multiplied things times 5, we broke these up into smaller pieces. Each of these bigger pieces was divided up into 5 smaller pieces. So that's really what we do geometrically when we multiply both the numerator and denominator by a number like this. We take our big pieces and break them up into several smaller pieces. However, when we do that, the total amount selected does not change. We've got the same amount of shaded region in both of these pictures, and so that's why these fractions are indeed equal. So there's nothing special about multiplying the numerator and denominator by 5. We can multiply by any number, call it n. Now we do need to add one qualification here, that this number n cannot be equal to 0. N could be a whole number, it could be a decimal, it could be a fraction, it could be a negative number, it just can't be 0. Now the next topic we want to talk about is comparing fractions, and we're going to use this idea that we just developed in part to compare fractions. And we're going to talk about 5 different ways of comparing fractions. The first one is the one that we're probably the most familiar with, and that's using common denominators. But that's not the only way to compare fractions. Another way is to use common numerators. Third is cross multiplication, and then a fourth is reasoning, and then a fifth is drawing pictures. So we're going to talk about each of these techniques briefly, how it works, and then a little bit about why it works. So the first technique, common denominators. Let's illustrate why we're using common denominators works by drawing some pictures. Okay, so let's compare these two fractions, 4/7 and 3/7. And so we can look at these fractions. We see that they have the same denominators, and so we know that the number with, or the fraction with the bigger numerator is going to be bigger, and so 4/7 is bigger than 3/7. But now the question is, why? Why does that method work? Well, let's draw pictures of these fractions, 4/7 and 3/7. So we're going to start off with a strip here representing a whole. 4/7 means that we're going to take that whole and divide it up into 7 pieces, and then we are going to select 4 of those pieces. And so this picture here represents that fraction 4/7. Now 3/7 means that we're going to take that same whole, we're going to divide it up into 7 pieces, and we're going to select 3 of those pieces. So there's a picture of that fraction 3/7. Now if we compare these two pictures, notice that first of all the pieces are all the same size, and that's because we started with the same whole and we divided the whole up into the same number of pieces, so we have the same number of pieces. Now obviously in 4/7 we selected more pieces, and so that's why the fraction 4/7 is bigger. We have selected more of those pieces. So to kind of summarize why method of common denominators works, if we have common denominators, then all the pieces are of the same size. And then second, the bigger numerator indicates that more pieces have been selected, and so that's why the fraction with the larger numerator represents a larger quantity. Okay? So this is why the method of common denominators works. Common denominators means pieces the same size. Bigger numerator means we have more pieces selected, and so we're going to have a bigger quantity. Now, some cases we're given two fractions that don't have common denominators. Well, we can easily find a common denominator. So let's illustrate how we can do this. Let's compare these fractions 4/9 and 3/5. And so let's take this fraction 4/9. And according to our argument here earlier in this lesson, I can take this fraction and multiply both the numerator and the denominator by the same quantity and get an equivalent fraction. Okay? Now, what number would I multiply by? Well, let's multiply by the other denominator, 5. And why do we do that? Well, you see here in a minute. Let's do this arithmetic. So this is 20 divided by 45. Okay? So the fraction 4/9 is equivalent to the fraction 20 over 45. So now let's take our other fraction, 3/5, and again we're going to multiply both the numerator and the denominator by the same quantity, and the quantity we're going to choose here is the other denominator, 9. So now if we do this arithmetic, we get 27 over 45. So you see that when we multiply by the other denominator, the resulting fractions are going to have the same denominators. And so now we can compare these two fractions very easily. They have common denominators. Obviously 27 is bigger than 20. So this fraction here is bigger than that fraction, which means that this fraction, 3/5, is going to be bigger than that fraction, 4/9. And so 3/5 is the bigger fraction. So using the technique we talked about earlier, we can always get common denominators and use that method to compare fractions. Now our next technique is common numerators. Maybe not as well known or commonly used, but is equally as simple. So let's compare these fractions, 5/8 and 5/9. Now notice that the denominators are not the same, however the numerators are. So let's draw pictures to compare these two fractions. So we're going to start off with a big strip here to indicate a whole. 5/8 means we're going to take that whole and divide it up into 8 pieces, and then we are going to select 5 of those pieces. Now 5/9 means we're going to take that same whole and divide it up into 9 pieces, and we're going to select 5 of those pieces. And so now if we compare these shaded regions, obviously this shaded region is bigger than this shaded region, and so that tells us that 5/8 is bigger than 5/9. Well, let's look back at our pictures and make a couple of observations. So first of all, in both these pictures we selected the same number of pieces. We selected 5 pieces here and 5 pieces here. However, let's compare the sizes of those pieces. From our picture we see that this piece, these pieces up here, are bigger than these pieces down here. And so when we have a smaller denominator, that means we have bigger pieces. And so if we select the same number of bigger pieces than smaller pieces, we're going to get a bigger overall quantity. And so that's why 5/8 is bigger than 5/9. So to kind of summarize these arguments here, if we have common numerators, that means we have selected the same number of pieces. However, the larger denominator indicates that we have smaller pieces. Seems kind of backwards, but larger denominator indicates that we have smaller pieces. And so the fraction with the larger denominator is going to represent a smaller quantity. So that's how the method of common numerators works, and a little bit about why it works. Our next technique is cross multiplication. And so let's illustrate how this works and then a little bit about why it works. So let's compare 5/8 and 5/9. Now we just did this problem, so we already know the answer, but so let's look at how we could find the answer using cross multiplication. And so we're going to start off with the fraction 5/8 and then 5/9. And so we're going to cross multiply. We're going to take, we can write it like this. And so on the left we're going to have 5 times 9. And on the right we're going to have 5 times 8. And now we do this arithmetic. 5 times 9 is 45. 5 times 8 is 40. Okay. Now we can easily compare those two numbers. 45 is bigger than 40. So that means that 5 times 9 is bigger than 5 times 8, which means that the fraction 5/8 is bigger than the fraction 5/9. Okay. So that's how we can do cross multiplication. Now the next question is, why does cross multiplication work? Well, let's use a method of finding common denominators to compare these fractions. Then we're going to make some comparisons. And so let's take this fraction 5/8, and I'm going to multiply by 9, both the numerator and denominator by 9. And so I'm going to have 5 times 9 is 45. 8 times 9 is 72. Okay, so 5/8 is equal to this fraction 45 over 72. Now let's take this fraction 5/9, and again we're going to multiply by the other denominator, 8. And so 5 times 8 is 40, and then we get 72. Okay. So now we've got these two fractions here that have common denominators. We can compare their numerators. Obviously this fraction is bigger than this fraction, and so that means that 5/8 is bigger than 5/9. Okay? And so the point here is that this arithmetic, 5 times 9 and 5 times 8, that's the exact same arithmetic that we did when we cross-multiplied. So what this illustrates is that when we're cross-multiplying, what we're really doing is finding common denominators and then comparing the numerators. So cross-multiplication is really just a shorthand approach for finding common denominators and then comparing the numerators. So here, just to summarize the point here, when we cross-multiply, we get the numerators that we would get if we found a common denominator. And then the larger numerator corresponds to the larger fraction. So again, cross-multiplication is really just a condensed version of finding common denominators and then comparing the numerators. Now, we don't always have to do arithmetic to compare fractions. Sometimes we can just reason through it. And so to illustrate reasoning, let's look at this simple example of comparing 4/9 and 1/2. Now, the fraction 1/2 is what the book calls a landmark fraction or a benchmark fraction. It's a fraction that we're used to working with, used to thinking about. It's easy to work with. And so let's just think about 4/9, how that compares to 1/2. Well, this denominator 9 means that I have taken my whole and divided up into 9 pieces. So if I would have selected half of those pieces, how many pieces would I need to have selected? Well, half of 9 is 4.5. So what that illustrates is that the fraction 4.5 over 9 is equal to 1/2, right? Just by reasoning through it. Half of 9 is 4.5, and so this fraction here should be equivalent to 1/2 just by reasoning through it. But the fraction that I actually have is only 4/9. So how does 4/9 compare to 4.5 over 9? Well, 4.5 over 9 is going to be greater than 4 over 9. And so in the end, what we have is that 1/2 is bigger than 4/9, and so 4/9 is less than 1/2. So there's how we can reason through comparing of fractions. In our activities, we're going to get more practice in some more techniques for comparing fractions through reasoning. This is just one simple way of reasoning through it. So our last technique is to compare fractions by drawing pictures. Now, we've already drawn a lot of pictures in this lesson, but let's talk about some important points about drawing pictures. So let's draw a picture to compare the fractions 1/3 and 1/2. And I'm not going to use strip diagrams here. I'm going to use a circle to compare these. So 1/3, what does that mean? Well, let's take a whole here, like a whole pie. 1/3 means I'm going to divide that pie into 3 pieces, and then I'm going to select one of those pieces. So there's a picture of the fraction 1/3. Now 1/2, what does that mean? Well, let's take the same pie, the same size pie. We're going to divide that up into 2 pieces, and we're going to select one of those pieces. And so now we can just compare these shaded regions. Obviously this shaded region is a lot bigger than this shaded region, and so that tells us that 1/2 is bigger than 1/3. So there's how we can draw pictures to compare those two fractions. But now when we draw pictures, we need to be careful that we draw the pictures appropriately. And so let's do an example of some wrong pictures that we might draw to compare these fractions. So let's draw a picture of the fraction 1/3. So let's say we got a big pie here, and we're going to divide that pie up into 3 pieces, and we're going to select one of those pieces. So there's a picture of the fraction 1/3. Now, to draw a picture of the fraction 1/2, what we might be tempted to do is maybe draw a smaller pie and divide that into 2 pieces, and then we're going to select one of those pieces. And so now if we compare these two pictures, we say, well, wait a minute, this region here is a lot smaller than this region right here. And so we might be tempted to say that 1/3 is bigger than 1/2. From our pictures, that seems to be the case. This piece here obviously looks a lot bigger than that piece right there, but that's obviously a wrong conclusion. Why is that wrong? Well, it's wrong because we started off with different size pies. Here we had a really big pie, and this was a really small pie. And so really what we're doing is we started with different wholes. The whole for this fraction 1/3 was this big pie, the fraction for, or the whole for this fraction 1/2 was this small pi. We can't compare different wholes. We need to start off with the same whole if we're going to draw pictures. And that's the main point of this last example. To compare fractions, the wholes must be the same. Now that's not saying that the denominators have to be the same. Remember, the denominator is not the whole. The whole is what we start with. The denominator tells us how many pieces we break that whole up into. We can deal with different denominators. We can always get common denominators, but what we can't deal with is different wholes. So we have to have the wholes be the same if we're going to compare fractions. So that's it for this lesson. Your assignment is to read sections 2.3 and 2.4. The book will talk about comparing fractions using decimals. But we're not going to talk about decimals yet until we do division. So just ignore any mention of decimals in the reading.